Okay, so today we are going to review the Pendulum Lab and discuss our findings of the Pendulum Lab. So, the research question again was, how does the starting angle affect the time of one complete swing? The variables were the starting angle was the independent variable, and then the dV was the time of one swing. The controls for this lab were the length of the string, the object that we used on the pendulum, and the person who drops the pendulum. For the hypothesis, you created a hypothesis based off of what you think was going to happen to the time as we increase the starting angle. Some of you might have said that it increased, some of you might have said decrease, some of you might have thought that it just stayed the same. And then here are just some vocabs for you to remember. Our findings found, though, that we have this pattern, which is a straight line with no slope whatsoever. This A value tells us that no matter how we change the angle, the time will always stay the same. Because if you look, the best fit line, which is a line that shows the trend of our data, is pretty consistently around this area. For our data from this is period one's data, the area it stayed around was 1.9, which was pretty accurate because when you look at our poster, the target time is actually 2 seconds. So this is called the horizontal pattern. What this tells us is that whenever we increase the starting angle, the time will always stay the same. So this pattern actually works for all other variables that follow a similar trend. We have 4 different patterns in this class. This is the first one that we're learning. So this right here is what we call the mathematical model. It's similar to what you would see in math class, which is why we call it that, where we use y and a is the variable that we use. If x was in this equation, or in the problem, it would be here as well, but x is not represented in here besides on the graph. So this right here is called our science model. The way that we find this is we just take whatever y is, which was time of one swing, we put it into this equation, and that's what it gives us this. Our a value is 2 because that's the only value we have for this pattern, for this one specifically. So it's 2. It will not always be 2. It kind of depends on the lab or the experiment that you're testing, but for the pendulum, it is 2. Okay, so let's talk about this again. Our pattern was horizontal. Our mathematical model was y equals a. The a value was 2. The slope of the line is 0 because it's a flat line, so there's no slope whatsoever. And then the science model is time equals 2. And then take a moment and try to predict. So if time always equals 2 at 120 degrees, what would be the time? If you said 2 seconds, that is correct because that would follow the pattern and the trend of this data that we have. And that is the Pendulum Lab explained.